Welcome back to the Automation Podcast. My name is Shawn of Insights in Automation, and this week on the show I sit down with Johannes Liegert of Paessler to learn all about their IT and OT monitoring software, PRTG. But before we get to that, I want to thank Paessler for sponsoring this episode, which not only underwrites our costs, but makes this episode completely ad-free. Now, if you folks out there listening and watching, if you appreciate vendors who sponsor our shows to allow us to continue to bring new episodes to you, then please take a moment and check out the Paessler product links found in this show's description. And with that, I want to welcome to the show Johannes. Thank you for coming on the show today, and I'm really looking forward to learning all about your IT and OT monitoring software, especially the OT side. But before we get into that, could you please just take a moment and introduce yourself to our audience?
Yes, hello, and thanks for having me, Shawn. So my name is Johannes Liegert. I'm the dedicated product manager for IoT and industry, so also in this case OT, at the company Paessler. And I'm already since 8 years and 3 months with Paessler. I basically started out as a developer, also before we're already a customer of the company itself, so a user of the product. Then went to the company, did there first as a software engineer, then went to the product owner of a certain team that develops the data acquisition capabilities. And now, since roughly 3 years, I'm the dedicated product manager for our OT customers to drive the success and make them happy. And by also going that, let's directly start with the topic. And as maybe a lot of you won't know our company, I want to just give a brief introduction to what Paessler is and who we are. So Paessler is a mid-sized European company. We are based out of Germany and have currently roughly more than 400 employees from over 40 countries worldwide. We offer the product globally. That means wherever you are on the planet, we can offer you the solution. And one number we are quite proud of is that more than 500,000 users worldwide rely on our product every day. So when we have a quick look on the facts, we at least see us as a leader in IT, OT, and IoT monitoring. And I guess that's the topic I will start on in a second, because why we drive these different things. And when we talk about the product, I also will talk about in a second. Then we speak about the product PRTG. And if you're wondering what PRTG stands for, PRTG stands for Paessler Router Traffic Grapher, and it's a pretty old name. Nobody actually in the company talks it or says it any longer in the long form, but it's just for us PRTG. And that comes in 3 flavors. So we have the network monitor, which is an on-prem solution. We have the hosted monitor if you want to have it running in the cloud. And if you are a bigger company, then of course you can go with the enterprise version. But so far, that's for Paessler. And I guess we should talk more about the product. So PRTG is a holistic monitoring solution that combines the elements of IT and OT into one view. And what I mean with monitoring solution is, as we have our origin from the IT market, is basically monitoring equipment. That means, as you can see in the lower section, like routers, switches, servers, HVAC systems, also cooling equipment. And when we drive to OT, also the PLCs, probably machines, HMI, SCADA systems, DCS systems, and all of the beasts and dragons that live in these environments, right? So by bringing everything into one view, we have the goal to reduce the complexity and the infrastructure cost, because you need less tools to make your operations run efficiently. And our overall goal in the end is that we want to ensure that your infrastructure is available and brings you the value you need. So when you're wondering how PRTG is structured, and I guess that's now a graphic we want to talk about, is like PRTG, the architecture is based out of basically 2 components. We have on the one hand the PRTG core server, which is our main software that gives you the visualizations, where you can look at your data, where you get alarms and notifications from, and where we store our data. And then we have the so-called remote probes, which are our data gathering components, so software components you can deploy on the field, on machines, so Windows-based machines, servers, IPCs, but also in the future on edge devices like PLCs, as I said, edge devices, or smaller like Raspberry Pi devices, where you can use to collect data and send them back to our core server that is hosted either in the cloud, as I said before, or in your on-prem data center, depending on where you need it and what you need actually.
So I got a question. So we have the PRTG core server, and this is probably in a server closet somewhere, and this is bringing all the data in from either the top floor or the shop floor, right? And so today you're saying that client piece or that piece of software that's in the field, let's say on the shop floor, that's sitting on a Windows PC today, right?
Yeah, so the core server, that's the
Hmm.
main central data storage. You say that's in the server room. That's Windows driven. The remote probe, that's the small agents I call it for now. That then it's easy to
Yes.
understand. That collect the data maybe in the cabinet or directly on the shop floor or top floor. They can either run on Windows or in the future. So basically this year also on Linux-based systems like what I mentioned with edge devices or PLCs.
What is the load of these distributed probes? Are they heavy loads? Do they need a dedicated system? And I'm guessing not, because they're going to eventually run on little edge devices. But is this something I could put on a SCADA system that maybe, or an HMI that's sitting on a Windows PC? I mean, does it need the full horsepower of an i7, or is it like a low priority task that will be, doing its job but not taking all the horsepower of the PC?
Very, very good question, and the answer I love the most. It depends, but usually we
Hmm.
don't need per se the horsepower of an i7, but it depends on what you want to do when we talk about monitoring itself. So for sure you can put it definitely on an IPC somewhere in the field or on the server you have your SCADA systems already running. So that will be for sure sufficient. But what I mean with it depends actually on what you want to monitor. So when as the audience is familiar with SCADA systems and DCS, right, you pull your OPC tags, Modbus, Ethernet IP, or whatever, right? All these
Hmm.
field protocols. And when we talk about monitoring, when we more look on the IT related side, then we talk about stuff like WMI, recurring data via SSH, SNMP, so other protocols. And by this combination, for example, WMI is quite heavy on the machines. So if you want to do a lot of Windows monitoring, to say if you have a lot of IPCs and Windows-based HMIs and you want to monitor them like hundreds, a couple of hundreds, then of course the load will be higher. But if you keep it on a slightly protocol, like just doing SNMP, or maybe even have the capabilities to go OPCUA, MQTT to collect the information, then of course it's way more lightweight and you can scale way bigger. So that's always the question of what you want to achieve, which data you want to collect, and based on that, the load varies. But all the things you mentioned are usually sufficient to monitor hundreds of devices. Definitely, yes.
All right, thank you. Appreciate that.
Okie dokie. So when we talk about why we are also on the show and what makes us unique and brings you the benefit is actually that we say for the unique selling points, we can say licensing is based on sensors. And I guess that's a very important topic for this audience here today. So when I and the company and we talk about sensors, we do not talk about physical things like a temperature sensor, humidity sensor, vibration sensor, so all the things we are used. No, in this case, we talk about sensors as um, a software piece that collects certain aspects of a device, right? So a sensor could be a CPU sensor, meaning the aspect of monitoring the CPU load of a system, or a certificate sensor checking the certificate validity of an OPCUA server, right? So sensor in our terms is not the hardware thingy, but it's more like a combination of various metrics we collect and build basically. I mean, that's a fancy buzzword. You could say that's the digital twin of an aspect of a device, right? But that's a too
Mhm.
fancy word for that, I would say. So that's a definition of a sensor quickly for the reference, because I will mention it later quite often. So then what makes us unique is that we have predefined sensors for OT equipment. Predefined sensors means that basically a boilerplate or a template to already collect certain metrics without having the predefined knowledge before, right? So if you want to say, I would like to monitor now my backoff PLC, right? Then you would need
Mhm.
to worry about, okay, which protocol do I use? Where do I get the data? Which data points do I need, right? And for example, we offer a predefined sensor for backup. So that means in the end, you just need to provide the proper port, in this case, OPCUA 4840 or 4852, if needed credentials. And then we have predefined metrics we just collect for you, right? Like the CPU load, the memory space, the rate status of the PLC, right? All these crucial metrics you need to ensure operational availability. That's already predefined by us. So you do 3 clicks and then you have all the information in place. So that's also a big point for us. Then we go with a cross-vendor solution. So, or we are a cross-vendor solution. So we are not bound to any certain vendors in the market, but we are independent software. That means wherever you have a Rockwell equipment, the Schneider Electric, a Siemens, we don't mind, right? As long as they support the protocols we support and can gather the data, you're fine with us, right? So we are not bound to any vendor. That's also a big benefit. And we provide all systems at a glance, right? So as I said before, we can cover the IT side and the OT side, and that is for the future way more important. That's why I also go for the next slide directly, because there's now the big times and the big buzzword times of IT OT convergence, right? And you can ask 10 people what IT OT convergence means, and they will give you probably 5 to 10 different answers depending on where they are and which kind of company. And for us, IT OT convergence is basically the chance now to not fight each other any longer, because that's the funny stuff you hear mostly, like people saying, "Oh, IT, go away! You have no idea what we're doing. Never do an update." Blah blah blah. Right? And on the IT side is the other way around. Like, you OT folks, you have no idea about security. You don't care. Blah blah blah. And in the end, our mission, so to say, when I talk about this term, is to say, like, let's unite and work together and bringing the values back to the company, because I guess IT won't go away, even with IT and OT. It won't go away. It's just, it will grow, and all the things we have now with machine learning, digital twin, and it's there and it will grow, and that's why we need solutions that help us work together on the challenges of the future, right? And bring that together. So that's how we see IT OT convergence, to bring the teams together, to unite them and bring them a tool that helps them doing their job in a better way, so to say, right? I guess we can clearly bring that on the point when we talk about holistic monitoring of IT and OT, because as I just said, it's connected now and it will be connected even stronger in the future. Because if you say you want to do data analytics, machine learning, and you have the stuff in the cloud in the future, then of course you want to ensure that the data from the sensors, so now I'm talking about the hardware sensors or the field devices, is actually reaching the cloud, right? To all this data processing and machine learning training, right? And that's the approach we actually say that's why holistic monitoring is crucial for the success of a company in the future, because only when you can ensure that data flow is working from the edge to the cloud and back, or even just from data centers, it's the same in the end. You need to ensure that, otherwise your business will be disrupted in the future, or you cannot gain the insights you need to make your production more efficient, right? And that goes also in the way when you talk about the security stuff, like the NIST special publication 882. I mean, I would assume a lot of people know that probably, when we talk about different phases you need to do to ensure secure manufacturing sites. And one point is 6.3, meaning detection. And detection means being aware of mishaps, of issues, of anomalies, right? And this is where we actually tackle a topic. So let's have a quick run through the edge to cloud scenario, right? So if I want to ensure that my companies can efficiently work with the data and derive the insights, then I need to ensure that my enterprise IT, so the top floor, cloud health, and the cloud connectivity is working, right? So I need to ensure that. Then one level below, and I guess that's for the audio listeners only. So on the right side, you see now a automation pyramid, and basically what I'm just doing is talking top down through the different steps you need to do to ensure the overall availability of your site, right? So when we go from the cloud, we go to the business application. So if you have an ERP system or SAP, you need to ensure that these are up and running, because there are many examples already out there that the downtime of the ERP or SAP system, or just a malfunction there, can have quite big impacts on your production side, right? If you don't get your orders, what to produce and stuff. So that's quite important to have that up and running. And this is typically an IT topic, right? It's not an OT topic, it's more an IT topic, but it's inside the whole value chain of your production side. Then, of course, we need to ensure secure communication between IT and OT. So there are many reference architectures. If you look on the Rockwell side, if you go to Siemens, they have these standard architectures that say, okay, you need to have a DM set in between with a top firewall and a lower firewall and stuff, right? And of course, setting it up is one thing, but also ensuring that the data flow is continually doing, that the firewall rules are properly set, that data is flowing through, and that the devices are healthy is crucial to ensure this bridging the gap between OT and IT in that regards. Then when we go to the more operational side, like checking the availability and security of a SCADA system, and now you would say, of course, my SCADA system is redundant, my DCS is redundant, it's never ever failing. But of course, still knowing that the action thing kicked in, right? So you're on a backup system can be crucial information you would need to have, right? Because if the second node or the third node also crashes, then you're gone. So it's also good to know that you are already in the backup mode and the cluster actually worked, right? That's good to know. And also security-wise, it's crucial when we talk about the more modern technologies like OPCUA or MQTT, when they talk with certificates, so you have trusted communication flows, then you need to also ensure that these certificates are valid, because what happens if a certificate runs out, the communication will break down, right? And that's also a worst case scenario. Like imagine having a production stop just because you didn't care about the certificates and they run out. That's for such a small issue, a huge impact in the end and the production run afterwards. And the same what we did or can do for SCADA and DCS systems, we can do also in the same way for PLCs and edge gateways, right? So they all communicate with the same protocols. So you need to ensure certificate availability, or you can check certain error tags in the systems, like because mostly I would say when people connect their systems to the SCADA DCS, you check more for the actual process values, right? And of course, the health of the devices itself is also part. But with our solution, you can add another layer of defense when it comes to these devices, like the temperature of the PLC or the edge devices, right? How many traffic is flowing through, if there are any timeouts on the network sessions you could identify and follow up, right? And when you combine all these different steps, you get a basically edge to cloud view. And that's what I want to showcase basically in this slide. So a little bit more hands-on when I talk about sensors, like what would you actually check? So again, for the audio-only guys, I go through a small now from bottom to top actually. So from the edge, what you can monitor on the devices up into the cloud systems with our system. So when we go into the cell level, we could talk about, okay, we want to monitor a PLC, so the health and the security, and what can you do? So I guess that what most people know is, okay, I could network-wise check with a ping, so just to see if network heartbeat actually, like if the thing is responsible over the network, reachable over the network. That's a good step, but either it can be not allowed due to security reasons, or it's just telling you the cable is plugged in, but nothing more, right? And if you dig deeper into the PLC, like checking a certificate via OPCUA, or checking the OPCUA server status to know if it's really up and running, if you can actually collect data from the system, you might check the cycle time tags of the system, or if there are any fault status tags on the PLC, so you can pull them out and bring it into our system to know and ensure the field level, so PLC level, control level is up and running, right? So then we go one step above and say like, okay, now if I know my PLCs are running, and everything's fine, how about the network connecting all the things, right? So there we want to ensure the ring topology is up and running, right? The switches are working fine. There's no traffic overflow. So we can check, for example, the CPU load, the port link status, how many traffic is running through, and all of these little things to know like, okay, my network is fine. And then we go to the next layer. And so let's check the DMC in our local data center, for example, right? So we can check on the IPCs and on the servers, like the CPU load, the memory, if any services are stopped, right? If the disk is enough, right? If there's disk free, if a web server is available. And also these are things like web server availability. You would say, okay, who cares, right? But nowadays, with all the fancy SCADA systems, they're all web-based, right? So every SCADA has a web server. So if you just want to know your HMI is working fine when it's web-based, just check if the web server is available and you will know it's working, right? And the same applies to all the other things like a firewall and so forth. And disk-free is, of course, sounds like a ridiculous, easy thing, right? But there are still big companies out there who oversee that and then are wondering why the whole production was faulted, basically because they just run out of disk space for the MES system. And these are very easy things you can solve by just doing a proper monitoring and getting alerted right on, right? And then we go to the last step, to the cloud services. So of course, you want to ensure if you want to send your data to the cloud systems, these need to be available, right? They need to be reachable from your side. And also if you use technologies like MQTT, the broker needs to be available, right? Certificates need to be properly set. And if you cover now all these single steps, you have an actual ensured edge to cloud value chain secured via monitoring. And I guess this can make a big impact when we talk about detecting the root cause of an issue, right? So this example we have actually replicated in Germany in a factory that have exactly this. So they have a cloud-based MES, and they send production values via MQTT from Siemens PLCs up to the MES and then back down to the HMIs. And exactly they replicated this approach. And now when they have an issue, they can pinpoint exactly what was the actual cause of the disruption, right? So they know even if the PLC, via checking the single components inside the program logic to select the actual port was opened by the PLC to the MQTT broker, right? They know if the network is working. They know if the MQTT broker is working. They know if the applications and the firewall in between works, right? So they can exactly pinpoint where the issue was coming from and what is actually going on. So from a business perspective, this makes a lot of sense, because if you can shorten the mean time to repair of equipment by just knowing exactly what you need to do, this can save a lot of time and in the end a lot of money, because you can be way faster up and running in the whole production, right? And of course, we are not the solution that can solve all the things on the planet, right? That's nobody can do that. But at least if you could say, if you can bring the typical downtime, if it's on hardware related like this one or network related like this one, from 30 minutes down to 15 minutes even, because you just know, okay, we need to switch the switch, right? Rip it out of the cabinet, place a new one, pull on the backup stuff, and then it's running again, right? If you reduce it 15 minutes, it's already, depending on what your number of money lost per hour basically is, then you can already save a lot of money by this approach, right? And what we can do also with our software is not just collecting data and getting alerts on, but we can also visualize in a certain aspect. And in this case, it's important to say we are not a replacement for the SCADA or the DCS, because they have their own job. The main thing is to control and monitor the actual production process, right? And our job is to ensure that everything around that's supporting the whole process is actually working. So we're not a direct competitor for SCADA system, but we can provide additional value to the system itself or the users in the end. So for the audio guys only here, I have 2 screenshots up of the interfaces you could build, the visualizations. And on the left side, we have basically replicated a cabinet where you can see the status of the single components in the cabinet, at least the network connected components, so to say, to make it clear. So you can provide such a dashboard, for example, to your maintenance guys. So if they get an alert, they can exactly see like, oh, this is this cabinet and this is the device on the top left and it's exactly this switch, and I know what's happening, right? So I know the over temperature or whatever, right? So they can pinpoint exactly what is the issue and fix it in the shortest time possible. And on the right side, we have a screenshot of the interface showing the current state of a sensor. And again, we talk about our sensor, so the software sensor that actually pings a device. And we can see like there was an alarm raised because the device is not reachable. In this case, it's reachable, but it takes too much time to actually reach the device. So this can be critical when we talk about, for example, vision-based systems, right? So if you have vision systems to inspect and control, you want to ensure that the latency is as low as possible, right? To have the fast thingies. And of course, delays in the network can have an impact on the vision system. So that's why you want to ensure that the latency in the network is as low as possible in that regards. And for the cabinet one, again, for the only ones, I have just a small replication from the real world into the visualization we have with the virtual cabinet, so to say, where you can see like, okay, this is the state on the real thingy, but if you're not in front of the cabinet using our approach, you can also, as I said, again, identify the state of the components in the end. Again, a small recap regarding security and NIST. So maybe you have heard about it or read also the things you need to ensure. So when you want to provide a secure environment on the manufacturing side, you need to have 5 big bullet points, so to say, you need to fulfill, right? So it's identity, identify, protect, detect, respond, and recover. And identify means like you need to know what's inside your network, right? Which assets do you have? Do you have vulnerabilities and all of these things, right? That's per se nothing we fulfill fully, but of course we can support in identifying the assets, because our software is capable of identifying devices in the network. So you can already get alerted by us by seeing, oh, there was a new asset added to get handle it properly. And then the important part is when we talk about protection and detection. Protection would mean rather you need to have secure remote access to the site, right? And what we can do here is to ensure like we can alarm you if somebody is on the system or if the remote access tunnels are breaking down due to network issues. So you can really ensure only secure remote access as possible to the site. And the main thing we are focusing on is actually the detection thing. So by continuously monitoring your whole site, your machines, your network equipment, your servers, you can ensure everything is working fine and detect anomalies if something weird is happening. And On the respond and recover side, respond means you need to inform the right people at the right time about what is happening, because it doesn't help you if you inform the maintenance guys about a certificate running out on the PLC, right? It's not probably their job to fix that, but you need to pinpoint exactly who needs what information at which time to resolve the situation in the fastest ways possible. And recover would then in the end mean that if something happened in the worst case, you need to recover as quickly as possible. And here we could, for example, provide a way that you can run custom scripts with our software. If we detect an issue, that means custom script means you can provide a PowerShell script to restart a service on your SCADA system, for example, or boot up another machine or whatever you need in your escalation flow, so to say, if everything breaks down, how to recover and build up the whole system. And when we talk about responding, there's one thing that makes us also unique, or we think it makes it better for your situation in the end, is that we, for example, since last year also provide additionally to our monitoring software an own dedicated OPCUA server. And the benefit is basically by deploying the UA server, you can use all our data we have in our system, means all the monitoring metrics and the states of the devices we monitor. These can be now exported using OPCUA into your SCADA system, your DCS system, your HMIs. So the true idea is, when we wrap up back to the beginning, when I talked about IT-OT convergence, is like, okay, making the life better for everyone, right? And our philosophy here is like, I don't want to push another tool onto the control engineers or whatever, right? They don't need to learn another tool, but they have everything in place they need, right? They have the SCADA, the HMIs, the DCS system. So why not just share all the information we have, our alarms, and make it integratable into the other systems? So you can basically build or enhance your SCADA or DCS screens. Like, so this is an example we have here for the, again, audio guys, 2 screenshots of a Siemens PCS7 DCS system. And what we did here is actually integrated information about the network devices into the DCS view. And three aspects we want to pin out here is like, what would be different to before? Because currently, of course, you could add using SNMP also this information to your SCADA, right? So certain DCS or SCADA vendors can also support SNMP to pull information out of your switches, routers, firewalls. But what we here have, for example, is that we can show the jump host activity, right? So jump host activity, would it mean if a third-party technician is logging in from remote, right, to update a firmware, change a program, you wouldn't be aware of that before, right? It's just he's doing a job, then he's basically closing down and goes off, right? And then suddenly a machine is behaving differently because he changed something, but you were not aware of that, right? And by monitoring, for example, the RDP activity on that system when he's logging in, you can be at least informed and say, there might be a traffic light turning yellow and saying, hey, be aware, somebody's doing activity on the jump host, just in case you are aware, right? And this also changes the whole situation then for the people because they're aware of that thing. Of course, we can visualize the ring traffic, like how many traffic is going through the network, if the switches are healthy, right? Because these are usually aspects that are not always covered into the systems. But in the end, it's always better to have all information in one place so you can make the best decision at the point in time of the issue, right? Because we had it in a customer in Africa, a big port, right? The port is like, I'm not sure, 5 kilometers long. And what they had the issue is like they have CCTV cameras out there, various telecommunication towers, right? And they have also UPS systems on these towers. And the challenge they had, like, what do I need to do if I don't know what the root cause actually is, right? So they need to drive 5 kilometers with the car out there to fix it. And the worst cases was like, actually, okay, I sent now out an electrician, send it to the site, and then he realizes, oh, an IT person would have been better, right? So he drives back another 5 kilometers, picks up an IT person, and brings him in and there, right? So by having this approach and getting the overall overview, you can easily decide, do I need a maintenance person? Do I need a control engineer? Do I need an IT person, right? And by this approach, you can save a lot of time and money and nerves in the end, because it's also a personal thing, right? And one thing I would like to add, and maybe also educate, because it depends on how many people know about OPCUA alarms and condition. So if you haven't heard about OPCUA alarms and condition, that's basically an extension of the OPCUA standard that allows you to forward the alarms of a system in a standard approach. So before it was OPC A&E, alarms and events, and on UA that changed to alarms and conditions. And we also support that with our OPCUA server. That means when our software PRTG is recognizing an issue like a device goes down or the disk runs full or a certificate runs out or a fault tag on the PLC goes up, then we can raise that alarm and you can easily integrate it into your DCS or SCADA in a standard manner because they support an OPCUA ANC in the end, right? And the benefit is here that I have, again, for the audio guys here, a small example. So assume it's on the weekend, probably Sunday, right? And the guy who is maintaining the network is not in the plant, right? So he's at home. And now the switch on machine 3 goes down. So by integrating our alarms into the SCADA system, the engineer sitting in front of the SCADA will now get alarmed saying, oh, switch in machine 3 is down. But now as he knows that this is the actual cause of the problem, he can decide on like, okay, we shift the next batch to machine 5 and because now it works out currently, so no problem. And the actual benefit of having ANC is you have basically a back channel to the issue of the issue. So he can acknowledge this alarm in his SCADA system. Then also the acknowledgement is of course tracked in the historian on their side, but also this alarm will be acknowledged in our system, so inside PRTG. So that means if there are two different users and then we come to the IT/OT convergence thingy, both systems have an alarm, both systems acknowledge the alarm and have the acknowledgement in their tracking. That means if you do an incident follow-up later on, you will see exactly when and who actually acknowledged the alarm with this message. And that's the point. You can enter a message by acknowledging the alarm, right? I mean, that's basic. I don't need to tell you about that. But this message is then also transferred from the DCS or SCADA system back into our system. So when you look into the log of our system, you will see this alarm, network alarm, was acknowledged by the SCADA operator at this and this time with the message, okay, I checked. It's not a power fault. It's not a mechanical fault. It needs to be an IT issue, right? And this saves tremendous time for the IT guy. And in this case, as I said, it's a Sunday, right? So the IT responsible person might sit at home on the couch watching television or is playing in the garden, right? But thanks to our app, so we have an app for Android and iOS, he's immediately also alerted about the issue in the plant, right? So he sees switch 3 goes down, but at the same moment, he also gets the message from the SCADA engineer saying, oh, I checked this and this and this, so it must be this, right? And then he can do the proper measures, right? So either he drives into the plant or he calls a colleague who can fix it or whatever, right? But the important thing is he's aware of what was already tried so he can do the right message and not just guessworking and trying to figure out what actually is the root cause, right? And again, that brings me back to this is the important thingy, right? To make people aware of what is going on at which time, and then they can do the proper measures and solve the issue. And of course, save the nerves in the end because everyone on Sunday doesn't want to run into the plant, right, to fix this easy stuff, only the hard stuff.
I got a comment for the audio audience. The switch 3 went down. The OT guy said, "Oh, I can take care of that. I'll just move the batch over to machine number 5 from machine number 3." And then the IT guy's like, "Great, I can stay in bed." So I love the humor in this slide. But let me turn it back to you, Johannes.
No, all good because it's anyway the last slide, so that I would have brought me to the question time because I guess it was a rough run through, so to say. But I guess that there are quite some questions you would, as you act for the audience, I guess there might be some questions definitely.
Yeah, I want to ask you some questions. So I really got a good idea, and I can see how you started on the IT side, and now you're moving into the OT side. And so I definitely have some questions for you because you may have one plant that's full of Siemens control systems and Siemens switches. You may have another plant that's full of Rockwell control systems and Rockwell switches. And then we just covered so many different vendors on this show. I don't want to name them all, but Schneider and Phoenix and just so many great people that's been on our show that, what is the requirement? I want to start on the network switch side. What is the intelligence that their network switch has to have to work with your system?
Intelligence is a nice word, but in the end, the basic requirement when we start on the lowest level would be just they need to be able to talk SNMP. Then we have the discussion, do you have unmanaged switches or managed switches? But so usually all the managed switches on the planet, at least the last 15 years should be, 20 years should be able, even longer, should be able to talk SNMP with us. The question is then in the end just depending on Security-wise, do you need to ensure SNMP v3 versus SNMP version 2? So for the guys who are not aware of the differences, so SNMP version 1 and 2 do not provide secure measures like encryption, and only with version 3 you get encryption. But of course, it's heavier load on the systems itself, so the switches itself, and also on our system, right? And then, of course, it depends. Do you have the ones, are you enforced to use v3? Can you go with v2? Depends always on the criticality. And of course, nowadays on the more modern network equipment, there might be also REST APIs, so you can go away from SNMP and go to the REST APIs to collect the metrics and alerts from the systems, right?
Excellent, excellent. Now, when we take another step down from the network switches, right? And you have these sensor templates for different PLCs. Do you have a list, like what are the major vendors and the major products from those vendors that you guys are trying to support now? Is it Siemens? Is it Rockwell? Is it Schneider? Who else? What are you guys really for those types of devices?
So the benefit or the approach we are usually choosing is like in the first place, we don't start out with the vendors, but we go with the protocols because luckily time changes, right? And more people agree on, okay, we use the standard protocol, right? So
Sure.
what we currently support directly in the software is Modbus TCP, Modbus RTU. I mean, if you need that still, MQTT and OPCUA. So by supporting OPCUA and like MQTT, you can basically already cover the majority of the vendors, right? So all the vendors have usually built-in OPCUA sensors, servers to get everything, right? Like a Rockwell. Okay, Rockwell maybe have, you need the links middleware, but at least Siemens, Phoenix, Vago, Schneider, all of these guys have OPCUA servers in their PLCs already, right? So you can pull the metrics out using OPCUA. For the dedicated ones, so currently we do not support Ethernet IP or native S7, but that's on our roadmap to integrate it because the demand is just there. People need it also for older equipment to get the metrics out of these, right? But usually with the MQTT, Modbus, and OPCUA approach, you can like get 80, 90% of what you have in the plans to get the information out of these systems, right? When it comes to single solutions, we have, for example, a direct solution for backoff in place. So you need basically 3 clicks and then you have your backoff PLCs covered, like as I mentioned before, CPU load, rate state, and so forth. But for the others, it's also straightforward. And the great benefit is for the stuff we do not provide, you can always build your own templates in the software, right? So you would just add your device. So in this case, like let's stay with the Siemens PLC, right? You connect the UA server and then you pick up the metrics that are available, and then you can save it and say save as template, Siemens PLC, blah, 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 right? And then you can just do a discovery, that's how we call it, and say for this IP range, because these are all my PLCs, please apply this template, right? And then you can add like 50, 100, whatever, how much you need, right? Automatically add these devices to the monitoring. And the cool part is with the templates, when you have the thresholds predefined, right? Or states you want to get alerts from, like by this temperature, I want to get a warning. By this temperature, I want to get an error message, right? By this state of the device, if it's in programming mode or where I want to get a warning state, then all this information is also saved into the templates, right? So once you configure a device, you can roll it out to hundreds of thousands of your devices and have all the same standard configured when you get alarms and so forth. So that's the great benefit and efficiency we provide in the end.
Yeah, that's excellent. I just for the audience, I know, and some of the audience may know more about this than I do, but Rockwell recently added the ability to enable OPC in some of their latest and greatest PLCs or PACs, Logix PACs. I'm not up to speed on that. I've reached out to Rockwell to get them on the show, but I haven't heard back. So I may just get one of the distributors to come on to kind of give us the details on that. And as you mentioned, I mean, we've talked about this on the show before. Siemens has OPC built into I know the 1200 and 1500 have the capabilities there. And, you mentioned some of the other people who make programmable controllers who do that as well. And then, of course, we've had, for the Rockwell folks out there, we have had the Factory Talk Links people on one of the previous shows, and that is just a great show to go over all your options with that new software. So in any case, if that's your fallback to that middleware, and again, you might be able to get some of that information out of your SCADA system or HMI too, right? Those are not just to display the alarms coming from the system, but you could also provide some healthy information from a lot of HMIs and SCADAs can be OPC servers, right? Them
Definitely,
themselves.
yes.
Yeah.
We have there a pretty cool customer in the APAC region. So a steel plant, if I'm not totally wrong. And they actually they have a Honeywell DCS, and they pull out bunch of metrics out of the DCS directly into us as a second layer of defense. So they know stuff like the energy consumption, how many CO2 is produced. Just to have a second layer of defense, if something happens on DCS and they don't get alarms, at least they get it from our system then, which is quite incredible and nothing I would have expected, but they do it this way and works perfectly fine. And to add on the OPCUA story, because I talked to much of the vendors last year already. So when we go to the DCS side, the majority also supports OPCUA clients, and the ANC part and the client part, at least, I guess all the major one will have it in 24 now. So luckily, the world is changing, and OPCUA is in that market also more adopted. So from that perspective, we all get covered. So when it comes to, for example, pulling even our alerts into the HMIs and SCADA systems, even Rockwell has it now. So good news there.
Yeah, I had one more question for you, and that is, let's say I want to know how a PC is doing, right? So we all know the PC keeps track of what it's doing, the CPU and everything that's going on, memory and whatnot. But how do you get that information from the PC?
Good question. And as I say, it's always about the protocol. So when we talked about the PLCs, right, you use Ethernet IP or OPCUA or Modbus, right? And the same applies for PCs or IPCs, because IPCs are just PCs. So depending on the operating system, that's the most important part. Or okay, let's break it down into three parts, because then it's an more interesting aspect. So when we talk about bigger systems, so like a server maybe, but certain IPCs have that also. So when we talk about more server size of things, then you have two ways. So we have on the one side the BMC. So that's a controller directly on the main board. So it's independent from the operating system, and you can grab metrics from that all the time, even if the device is powered down. So that's the fancy part, because it's directly embedded into the hardware. You just need to connect the network port, and then you can access it. So examples, because then it's more tangible, I guess, would be on the HP side, it's the ILO. On the Dell side, it's an iDRAC. And depending on what the manufacturing company is actually using, then if it's a Siemens or whatever, then you might have this also available. But the typical approach would be on the Linux side. So if you have a Linux-based system, it's SNMP again, or you can utilize SSH to collect metrics. And on the Windows side, it's usually WMI or WinRM, or you could also activate SNMP on the Windows systems to grab all these metrics. And the interesting part, I guess, when we talk about the software side more is, of course, CPU load, the memory, and disk space is important. But from the automation perspective, when we talk about a SCADA system, a DCS system, there are just way more components into it. And you can then also directly monitor like the state of a certain service responsible for one part of the system, right? So because it's not just the one monolith application, but there are usually small multiple services running, right? One is taking care of the database, the other one is taking care about the actual data acquisition services, the other one about the alert logic, right? And you can actually also monitor the single services to create a full picture about the state of the SCADA or DCS system. So that's also pretty cool then. So you can really then in the end pinpoint even from a SCADA perspective, say, I know my bare metal stuff is working fine, right? The disks are fine, CPU load is fine, operating system is fine. But then I know, the service is running for the database. Oh, the database is reachable. Oh, I can check the tables in the database. Oh, I can check the web application. So the web HMI is working on the SCADA system, right? And all of these things. And you get a full picture actually of the performance and the availability of the system. And you can replicate that to basically everything, right? From a SCADA to DCS down to an HMI, PLC. So that's actually fascinating me all the time, that you can actually build such a transparency into your value chain, right?
Yeah, and a lot of times that can be so helpful with troubleshooting. So, you may not need a system till things start going a little weird, and you're like, I really got to find a way to troubleshoot this, and you need data to troubleshoot, and that's where I think this is just a great product. Now, let me ask you this question. Let's say somebody's just watched or listened to this episode, and they're like, I really want to contact these guys and find out more. Who should they reach out to?
The easiest way I would say is going to the webpage paessler.com. and there is a OT dedicated site. You can say talk to an expert, but depending on where you are on the planet, of course. For example, for the US colleagues, we have a great colleague there, David Montoya. So you can check him out on LinkedIn and add in and ask him. So he can also then inform me. So we can even talk about a demo or whatever, right? Of course, you can add me on LinkedIn and ask me directly if you want. So just Google or LinkedIn on Johannes Liegert. Then you can reach out to me. But usually the best way is just go to paessler.com and get us there in the contact thingy, right? That's the easiest way, so to say. But of course, if you say, "Oh, I don't want to talk to persons," then of course you have the chance to go to the webpage, and we also offer a trial version to download, so you can try out the software. And the best part of it, we have also a free version available. Like if you know the Ignition guys and their small edition for the home thingies. We have a similar offering that's called the PRTG 100. So up to 100 sensors you can use for free as long as you want. And this could mean like 2-3 switches could be covered depending on how much you're monitoring, right? Or 2 switches, 1 HMI, 1 PLC. So just to get like for your home lab or your test environment to get going, get a feeling for it and see if the solution fits your needs, right? That's also an offering. And then you still can later on reach out to somebody and say like, "Oh, this is pretty cool. I tested it," and then we can figure out the rest with you.
That's excellent. Guys, I just want to spell for any of you who are driving or listening and not watching. I'll spell the company name. It's Paessler, and man, what a great product! I can't wait to see it in action. But Johannes, was there anything else you wanted to talk about before we close out the show?
I was just wondering, like, how many guests did you have speaking about RATs issues? So having issues with RATs in the network?
Oh, yeah, that's a great question. So to you, the audience, if you've had any, I'm not talking about rat nests. I'm talking about physical rodents in your networks. Let us know. We'd like to know if you guys are running into that. I don't see a lot of pictures of those because I don't think people like to share them because they're usually pretty gruesome. But let us know. Let us know if you're running into that. Have you seen that a lot with your customers, Johannes?
At least that's a funny thing why I point out, because I already got some customers who mentioned that. So we had one case where they had a big troubles with rats actually. So typically always on the weekend when the IT guys were not there. So they have various control systems. And one thing I learned with the customers is rats do not differentiate between copper and fiber optics. So they're not vegetarian or something, so they just eat whatever they get, right? And I've seen it across the globe, and from seaports to manufacturing sites, right? So that's incredible how these beasts destroy the networks. And they had exactly that issue, because that's why it came up. Like always on the weekend, they destroyed one cable exactly, and then the machine didn't work exactly how it should go, right? And then there were just mechanics or mechanical engineers there, and they had no idea what cable is broken, right? So they set up the software to see like, oh, the connection must be ripped between here and there, right? Between two switches, and then okay, let's figure out a solution for that, right? So you can save the time and fix it on your own. So that's the red story I always love. And I've seen the pictures from the customers. So that's pretty great and hard how these beasts work around in the data center or wherever they come in, right?
Well, I wish all of our listeners no rat problems this year because we got enough to work on. We don't need rodents too. But no, that's a great story, Johannes. Thank you so much for coming on and bringing us up to speed on this. It's a very interesting product. I think you're going to get some. I think some of our audience is going to reach out to you because they're solving a problem that using traditional methods would be really difficult and time consuming to do. So I think you're going to see there's a lot of interest with our audience. But with that, thank you for coming on the show.
Yeah, I have to thank you, and it was a pleasure speaking here.
Well, I hope you enjoyed that episode, and I want to thank Johannes for coming on the show and bringing us up to speed on PRTG, especially about bringing us up to speed on the OT monitoring side of their software. Very cool. Now, if you did enjoy the show, please give us a like, a sub, and a share. And don't forget to check out Paessler's links in the description. And if you want to follow me, you can always do so at theautomationblog.com/community. Right now, that goes to automation.locals.com, but we're considering creating a new community that everybody over at automation.locals.com will get into for free. And I also want to remind you, if you know anybody looking for PLC, HMI, or SCADA training, they'll find all of my courses over at theautomationschool.com, and you can now buy a coupon or a voucher for somebody else to enroll. So it's not just purchasing it for yourself, but you can now gift the gift of education to your colleagues and coworkers. With that said, I want to wish you all an awesome week. Stay courageous, stay fearless, and until next time, my friends, peace.